All right, thank you guys for joining. We're gonna go ahead and get started. We've got quite a few people online as well already, so just as they filter in here in the next few minutes, and we'll just get started, right? So I'll introduce myself here in just a minute, but first things first, I do want to just reiterate, this is a CRMCA, ASCC, and a Rocky Mountain ACI really not even a sponsored event. It's being hosted by all three groups. So very specifically, I'm just putting up our CRMCA antitrust. Essentially, for all groups, we're not here to talk about costs or competitiveness between products or sell you any products specifically. So any products that we might mention here, it is a generalization. Understand that. I know Mike has a couple of pieces of equipment that he's going to talk about, but he's got a list of several different ones. So there are options out there, but we're not going to be talking about cost differentials or anything like that. So please do keep that in mind, okay? So with that said, I know some of you guys are not members. I know there's at least one in here that won't be a member, but we won't get into that. We won't point him out. But just so you guys understand, if you are members, for you guys that are online as well, and please understand there's lots of benefits to become members. One specific thing that or actually two things specifically that I'll point out is ACI certification. For most any contractor that is out there, if you guys are certifying 2 to 3 individuals every year, it's worth the cost of that because it's about 40% discount on those certifications, just in that alone. We also have the CTAC partnership, which we'll talk about a little bit today as well as really a unified industry across the board. Here in Colorado, for the most part, we are very well uniformed across the board to share all of our information and really just stand in unison when we have issues with DOT or municipalities or standard changes that need to really happen. And we really do stand together to get that happening. Also, this is a Tech Tuesday. This is our very first Tech Tuesday. This came out of our technical committee. And so if you guys want to be involved in the technical committee, please do also stick around after our meeting here today, our presentation. We will have our technical committee meeting here right after this meeting. So if you guys want to stick around and see what we talk about, you guys are welcome to do that and get involved in that more in the future as well. So with that, we're going to talk about we're going to really go into Tech Tuesday, right? So this is initial curing, theory versus reality. That is the name of it. We are talking about essentially the requirements that go into initial curing. Okay, and that is initial curing of those specimens that are cast out on site for concrete placements. So it is brought to you by CRMCA, ASCC, and Rocky Mountain Chapter, as I already said. I am JT Mesite. I am with the Colorado Ready Mix Concrete Association. My history, I've been in the industry for almost 25 years. I was working on the testing side of things for about 15 years before I came on board with the association, and I've been running the ACI certifications since then. So as I tell everybody in our ACI certifications, if you have a question about any of them or ACI standards, come talk to me. I'll probably have an answer, and if I don't, I'll look it up with you. Okay. We also have Mike Hernandez here. I'll let him have the floor for just a minute to explain where he's coming from.
Sure. Thanks, JT. My name is Mike Hernandez. Grew up in Colorado, attended the University of Colorado Boulder, bachelor's degree in environmental design with architecture major, master's degree in civil engineering. Worked for concrete contractors for about 27 years. And for the last year, a little over a year, worked for the American Society of Concrete Contractors as technical director. Currently, we have over 700 members. if you read the engineering news record, the top 20 reporting to ENR contractors, 10 of the top 10 and 15 of the top 20 are ASCC members. A lot of self-performing general contractors as well. In total, in the neighborhood of $25 billion a year of concrete put in place by our members. And we have a small staff because the dues are not very expensive. So it's an opportunity to join. And we have many associate members as well, state ready-mix associations, people who sell products to concrete contractors on the chemical side or fiber side, or any really element that you can think of goes into concrete. We probably have someone like Caterpillar, who's another member, who would be represented with our associate members. And this initial curing topic has been coming up a lot in the last couple of years. So when JT mentioned that we should talk about it, agreed that this is something that needs to be addressed. It takes the whole team everywhere to make sure it's properly done, and we're going to go over that whole process.
And then we did have Mike Eads that was integral in putting this presentation together with us. He was going to be presenting with us today as well, but he did have a personal emergency that he had to take care of today. So he won't be here, but he is represented. So before I go on, I just want to reiterate that we do have a Tech Tuesdays every month scheduled this year, except for December. So this is a new program that we're putting on. This is our first one this month in April, but we do have several already scheduled throughout the year. We actually have Urs here from GCC that will be presenting on hot weather concrete next month as well. So thank you for doing that. But we do have all of those coming up in the future as well. So if you guys want to take note, there's a QR code there, and we'll have one at the end of the presentation for you guys to access as well. So again, this is initial curing, theory versus reality. I do want to represent or thank our sponsors. That is Build Block, Full Force, and CTL Thompson. I almost said GCC. That's next month, right? But thank you guys for sponsoring. If you guys are online, thank you. Build Block, it does have some flyers up here. If you guys are interested, please do grab some of those for them. Thank you for coming in person as well. Much appreciated, Joe. So thank you guys. So let's just get into it. We talk about initial curing. How long? We've been talking about it for years upon years. There's never a problem until there is a problem, right? Let's just look at it very specifically. That it means that it's not a problem in itself, but the attitude and the actions taken or not taken that cause these problems. By the way, when I was quoting this, I realized I needed to quote somebody, and I realized that Captain Jack Sparrow actually did state this in one of his movies. So that was not on purpose, but that is who quoted that. So let's just take a quick look at some of the examples. What do we see out on site first, before we actually get into requirements and everything? So first few slides here, we got some pictures. I wanted to share really some examples of how it should look, right? And all of these pictures that you're going to see in the next few slides are from Colorado, just so you know. We've seen it all, okay? Here, we'll see that there are initial curing areas. We've got temperature control, temperature monitoring. They're in specific areas where they're actually either submerged or in a temperature controlled environment in a heated control area, okay? In the winter time, a lot of the times you have to use some other thing. You can't just use water in the winter time, right? Because it's going to get cold just as much. So you got to have some type of insulation. So these are some examples of some of those opportunities for insulation. Note, there are temperature control units in these areas, okay? But then we start getting into the more questionable. This is where you got to start asking the questions. Do these meet requirements? I would love to rip open that bag, wouldn't you? I don't know what's in it. Nobody else does either. But for all of those others, it's like no matter if it's a water cooler or installation, you've got to make sure that they're fully covered in order to meet those requirements that our standards require. Then we go into even further questionable actions. Did they even try? Right, Mike? Isn't that what you said? And it's like, did they try? Did any of these try? I'd say 2 of them tried. One's in what at least started in the shade over there on the right side, then on the bottom with the cardboard over top. It's like, I guess they tried, but they're still exposed to the exterior weather, ambient weather. They can't be. They have to be in a controlled environment. And we'll state it again and again, 60 to 80 degrees. That's what we're looking for. This is not going to keep that control. And it's like if some of these cylinders stay out in the sun for all day, now all of a sudden they're going to increase temperature excessively during the day. Then in the winter, or not in the winter, but in overnight. And it's like it gets cold here, even in the summer. Those temperatures are going to drop significantly. Now they're gonna rise back up tomorrow morning before they even get picked up. And it's like they have to be in a controlled environment, and that's what we want to look for. Some other scenarios that we've got to look for. And it's like, yeah, they've got a cooler. They might have water completely filled in, but does anybody in here can tell me what you see wrong here? In either of these pictures?
Not level vibrations,
What's that?
not level in their vibrations.
There's potential vibrations, yes. And it's like, and not level, yeah, we don't even know it, we could say that that's level, but are those guys that are doing the forms, they gonna need those forms today? Are they gonna need them tomorrow? Those cylinders are going to be moved. Then the ones on the left, they're right next to the placement. And it's like, they're standard cures, but they're right next to the placement. They gotta strip those forms probably, probably tomorrow. Now those are gonna have to be moved. You can't have them sitting in areas where they're going to be moved, disturbed, vibrating, or anything like that. So we've gotta pay attention to these scenarios as well, right? Now the most important one. Yes, we see it. Yes, these were really here in Colorado. It happens. And we just take pictures and walk off. And it's like, we have to start doing something and it's like, no matter what part of the team on a project you are, you've got to start saying something, just like safety out on a project. You have to start saying something. Otherwise, this is just going to continue, right? So let's get into some standards and specifications. I'm gonna hand it over to Mike, let him go through all of this stuff.
Sure. So let's, I guess, just distinguish between standard curing and field curing. They really do have 2 different purposes. The standard curing is to ensure compliance that the ready mix delivered to the site is meeting the specifications, and it has a the standards are really based around the 60 to 80 degrees around the standard curing condition before they're sent to the lab to be in either even tighter controlled environment. And since there are some people who are registered from the CDOT, AASHTO T23 is what's currently referenced in the CDOT specification. The AASHTO standard naming was changed last year. It is now T100 for making and curing concrete test specimens in the field. You can get that for $77 from AASHTO. So field curing would be basically ensuring that what the concrete in place is doing is represented by the cylinders that are maintaining the same conditions. And that's typically used to ensure that you have adequate strength for formwork removal or post-tensioning or both.
Sorry, go ahead.
So these are the applicable ASTM standards, and I will spare you from reading all this information, but in general, what sort of the personnel certified, they should be capable of doing the test and performing them as they should be. Locally JT could provide the ACI certification. Sampling, this seems to be something that's always a challenge. The temptation is to get it right off as it comes down the chute, the first drop of concrete. That's really not how the test is supposed to be performed. It's supposed to be in the middle portion, and you're supposed to have at least 2 samples that are mixed as per ASTM-C 172, and then ASTM-C 31 will go into initial curing and protection of the cylinders. So again, I'm not going to read all this information, but the big points to take away: 60 to 80 degrees, and that should be controlled. In a few minutes, we'll get into what the impact is of being outside of those standards. And they're even tighter when you're dealing with high strength concrete. Part of the reason that I'm even interested in this topic is a lot of the industry has seen a transition from a STM C150 type 1-2 cement locally, like a 2.5 here in California, or a high sulfate challenged area. And now we're using a ASTM C595 1L cement, and it does seem to be more sensitive to that initial curing. So whether the portioning was done differently to compensate for that modified cement, or just that the material itself seems to be a little more sensitive to temperature variation, to generating results that may not be consistent with ones that were obtained after coring. It's a general observation that I am actually working on a research project to validate some of that. The temperature control and kept in a moist environment, lid on, ideally submerged in water. One place. Okay, so within ACI 301, it references ASTM C31, and also in ACI 318 references ASTM C31, all going back to those initial curing conditions. Those 2 ACI standards are pretty much going to be in any specification you'll see on the building side. ACI 132 goes into whose responsibility is it for this testing environment. So the engineer of record or the contract could determine whose responsibility it is. That could be either the spec or the contract to modify this, but this would be the default. If no one says otherwise, this would be the default. Frequency of cylinder tests, so it'd be like every 50 yards, every 100 yards, minimum once per day is pretty common. Any information needs to be on the lab reports, or if there's, for example, low carbon concrete, you may give an exception to go to 56-day strengths as opposed to 28-day strengths. Contractor, when they say contractor, it's typically talking about a general contractor. To organize a pre-con meeting, we're going to get into that more later. That's an extremely valuable meeting to confirm everyone's expectations about what's going to happen. Contractor responsible for informing the lab that the day is the placement, so they're there to do the sampling and of the plastic and acceptance cylinders. Providing location for water and power, this can be a big challenge, especially in the starter projects. Initial power may be running off generators. So even if everyone's getting the best market available, temperature controlled cure box, most of those require power 24/7. So if everyone's shutting the generators down at the end of the day, basically throughout the night, you're going in an uncontrolled environment, and probably on the weekends, the power is being shut off the generators. So, Saturday and Sunday, you'll be in an uncontrolled environment. So get the expectations established early, so there's not a surprise if you're suddenly realizing that, oh, every day at 5 o'clock and every Friday at 5 o'clock for the whole weekend, we're dealing with an uncontrolled environment, even though you have the right equipment to perform that. So basically you have to make some kind of alternative arrangements. And then the need for water is readily available. for a lot of the water cured systems. And then basically just confirming responsibility for maintaining who's providing the materials or maintaining them. So the pre-con meeting, extremely valuable meeting, get the whole team there, really about the owner, engineer of record, general contractor, concrete specialty contractor, their finishers, finisher foreman ideally, testing agency, ready mix, everyone who's gonna touch this material, just to make sure we're all agreeing. Can we have water? Where are we gonna test? Where's the washout? Again, frequency of cylinders, is that place where they're gonna be storing them, gonna be protected? And then we'll get into how are we monitoring the temperature itself? You can be compliant with the standard, something as simple as a high-low thermometer. Now, I would argue that that's giving you the data point for the coldest second of the day and the hottest second of the day. But everything in between is, your guess is as good as the next person's, as far as if it was almost always too hot or almost always too cold or almost always just in the right zone, but just for 5 minutes when they opened the door and put it back, it was hitting that high or low. You just don't know unless you have continuous monitoring. So, again, per ACS standard 132, 305, 306, these are all things that you want to establish expectations early, just to make sure the teams agree with what's going to happen. We touched on this a little earlier, but 68 to 78 degrees is the even tighter temperature range for high strength concrete, 6,000 PSI and higher. And if you're looking for extremely high strength, you really got to hit this window, or there's a very small chance that you're going to get accurate test results.
So I'll just reiterate one last time in regards to those responsibilities. That pre-construction meeting is really very, very important in regards to what Mike said, and for all of those situations, but also determining who's responsible for what as well. Specifically, like the power, which is stated in 132 that it's like it should be included as power supply by the contractor, but is it really going to be 24/7 power? And it's like, are they going to have a generator out there where they're gonna turn it off at 5 o'clock at night because they need to turn it off because of safety concerns and a potential fire issue? And it's like, if that's gonna be the case, you have to figure out different methods. So you have to talk about those, and they should be talked about at those pre-construction meetings. So let's go into some of the real numbers that we've seen. Yes.
There was a slide, it was the point of discharge versus the point of pump, and it had a parentheses. Yeah.
Always
The
push for
fourth
backup.
bullet, yeah. Is that still in contention?
Yes,
Oh, we got through that.
it is still in
Every
contention.
job.
If you're working on a commercial job, and from my understanding from Mike Eads as well, is that he deals with it on every single one of his projects with GH Phipps, is that if there's a pump on site, they want to, the engineer wants to sample it out of the pump.
It's not Phipps.
It doesn't matter. What's that?
It's not Phipps.
Oh, no, I mean, he's seeing it, it's not Phipps that's forcing it, it's the project engineer that's trying to push to sample out the end. So there are those contentions of where you should be sampling. And from a representative from the producers, my answer is from the back of the truck, because that's what's being delivered, that's what you're paying for. And it's like, but from an engineer, I understand taking it out of the end of the pump, because that's the point of placement. That's what's actually going in.
Best quote I
So-
heard was, are you actually testing the mix of the concrete, or are you testing the structure of your engineering?
Mhm.
That's,
Yeah,
is the concrete doing what it's supposed to do, or are you worried about your structure? not doing
yes,
what it's
exactly. And that's one conversation that has to be happening, is that it's like acceptance testing is happening out on site to verify that the concrete that was ordered is the concrete that's arriving. Not that it meets other specifications or requirements that the engineer is wanting inside of a placement. It is what is being delivered, that is the verification. That's why we make cylinders at every port, is to validate that that concrete that showed up is consistent and is what is specified per the project.
Or in case when an engineer record says, I want to, do you test it both ways then? I mean, what do you guys do?
There has been, ACC has a position paper that you can do a correlation, that you basically test, okay, with this size of pump, and we're testing it at the back of the truck, and at the end of the pump, we're losing 2% air and 1 inch of slump. So if your concern is the air at the point of entering the structure, you would want a correlation of 2% more air going into it, and possibly one inch more slump going in the system to get that output at the outside. But you would know what your, in theory, that loss is. It tend to get more variable results in like an A-frame pump setup as opposed to like a horizontal pump setup.
But there's so many variables associated with it, with the pump setup, and there's a big, I think it was CRMCA, McCombs gave it to me, an article with, it regains the air that's lost is entrapped. You're regaining that air, regains it once it goes through the pump, and you try putting that responsibility on a pump company. Once it touches your pump, it's your concrete. No, it's not. So I mean,
Yeah, that's a published correlation paper, is that correct? That has some of that
I mean,
information?
it's a suggestion for how to
Yeah.
deal with this, with the challenge of
Yeah.
Yeah,
wanting to,
And-
want the, in the building or what's delivered, and it's going through a big pump system.
yeah, and what I've suggested in recent years since we've really had this issue is exactly that. Do a correlation on site, just like you're doing a test placement. And it's like, for the first 3 days, have 2 guys out there, one testing at the truck, one testing at the pump. Correlate those, figure out what that difference is, and as long as that, as he said, as long as that pump doesn't change directions in regards to vertical versus horizontal.
Yeah.
And it's like, you're going to see that correlation consistent throughout the project.
CDOT even got rid of that specification, didn't they?
What's that?
CDOT got rid of that specification. Testing at the pump.
Correct.
Good topic for the pre-con meeting to figure it out
Yes.
before you're
That
on
is
site.
absolutely a good conversation to have at the pre-con. Pre-con should really be a lot longer than, honestly, pre-cons that I've been at. So, and for anybody that works for CDOT, it's like the CDOT meetings, they might be a little long for some projects, but they don't emphasize this part of it enough, honestly. And it's like they talk about all of the other inspection items for all of the other ticket items, but they don't talk about testing. And this is something that I'm very passionate about in regards to testing specifically personally. And it's one that, and it's like, I will say over and over and over again, that testing agencies, they are maybe 0.5% of an overall project in cost. And it is one of the most important things on a concrete project. And it's like, so there is some variable that we have to get past and figure out the solution to it. So let's talk about some real numbers. We're talking about initial curing, we're talking about the specs. We get it. There's problems going on out there. We know that there's specifications that aren't being met or standards not being met. How do we curb that problem? How do we fix the problem? First one is communication. We already talked about it some with the pre-construction meeting. Second opportunity is really, I'm gonna point out CTEC. No, I'm not selling you a product, okay? I'm going to reiterate that right now. This is not a product. This is a tool that we share openly to all of our members here in Colorado. This is now a national program It started back in 2015. We've gone national in 2022. We currently have 11 partners. We are actually onboarding 2 more in the next 2 months. So that is, look at it as associations in different states across the country. And I say North America because Quebec, Concrete Ontario is part of the program as well. They use it up in utilizing Canadian standards. So it is something that is being seen as an issue across the country. And it is an app that utilizes observations on site. You report that information and it gets submitted to a central location. It is designed as a tool to assist improve consistency, not necessarily to solve the problem. This is not a tool that as soon as you get involved or you do that observation, things are gonna get solved and things are gonna be fixed. It's not gonna happen that way. It has to be used appropriately. And it's not a finger pointing device either. We're not here to point out to the testing agencies that they are doing things wrong. They're not always. But sometimes they are doing it wrong, but they don't realize it either. And if we have information to show that, hey, on this project, we're seeing a consistency of this not happening, and in regards to initial curing, what is happening? Can we fix it? Let's have the conversation. Let's now fix the problem because we see that there is an issue, because we have data to back it up. And it's like for years upon years upon years, and it's like we've been talking about testing and initial curing not being done correctly, but we haven't had the information to back it up. Now we're starting to collect that information. We actually have that backup, that information now. So some of those items that I had already talked about, I'm not gonna go through go over all of these, but a couple of specific things. CTAC, it is a tool. It utilizes field observations. A lot of things that people tell me is that, oh, well, we don't want to use CTAC because we don't have the manpower. Do we have to pay for somebody else to go out to all these other job sites? No. It doesn't take any more time than what you're already spending out on job sites. And so if you have a QC going out to a job site to observe testing, guess what? He's already observing testing. Now he can just pull his phone out and take pictures, go through the questionnaire, all that stuff, and really just do it while he's performing the tests. Same thing for QA. If we have a supervisor for our QA or for our testing agency, if there's a supervisor that goes out and checks on his guys every once in a while, he can do the exact same thing. He's already going out there. If you're authorized on a project, there's no reason not to do it. Okay? And that's the idea behind it. So some of the numbers, what are we seeing? I'm going to show you a couple different charts here. One in Colorado, based in over the last year in 2023, so the entirety of 2023, and then across North America in 2023. What have we seen? So this is information that we've seen and that we saw in Colorado over the course of 2023. 82% of the individuals observed were certified. 65% of them sampled correctly. And Mike said something about that earlier, right? And it's like, you've got to make sure that sampling is done correctly. Physical properties tests were done correctly 85% of the time. And then the topic that we're talking about today. Anybody want to read that number out for me? I just can't stand looking at it. 24% of the time in 2023, last year, observations show that we were doing initial curing properly 24% of the time. And we can even break it down to improper facility. 42% of the time, they didn't have the proper facility. They didn't have the cooler, the water, the combination of the insulation and the shade or the heating conduit. Temperature control or monitoring, 20% of the time they didn't do that. They didn't have any of that. And then 15% of the time they didn't have either of those done correctly. Right? That's terrible, right? You think, go ahead.
To me, JT, that means that 3/4 of the time, that testing lab wasn't given the support they need from either the owner making a commitment to buying the right, paying them to have the right equipment there, and then the construction team not giving them the water and power they need to maintain that equipment. 1/4 of the time, that was all of those criteria were met and they do proper care.
And the owner not enforcing, or somebody not enforcing and saying this can't happen, because they're obviously continue to do it.
Yes.
Yes,
Do you send this out to the testing agencies throughout Colorado, just the overall?
I do not send the overall, I do not send that out. We have a board report that we share monthly with our board of directors, which includes 2 of the testing agencies.
So if they're not,
In Colorado, for each of the individual companies in Colorado and across the country, if they want to be involved, they can get a login and have access to their own information, yes. And see their comparisons as compared to all of the other companies on a whole average.
how many have gotten usernames and passwords to look at their individual information that aren't on the board? If you can share that, I guess.
For testing firms here in Colorado, well, that's a double-edged question because when it was a Colorado program 3 to 4 years ago, we had about 10 different testing companies that were regularly asking for the information before we actually had logins for them. When we went to a national program, at the same time, COVID was just recovering and we were going national. And what we were noticing is that a lot of testing firms changed over management. So the companies that are out there, at least here in Colorado, are not the same managers that we've worked with in past years. So I'm actually in the process of reaching out to a lot of them to get them back involved. So it's past, future type of answer there for you. Yeah.
Thought I'm doing a presentation in front of CAC
Mm-hmm.
and just say, it's an ACI, here are the requirements. And, it's not happening on your job, contractor shall do this, but it's not happening on your job. When are you gonna start enforcing on behalf?
It turns into a matter, and yes, I'd love to present this program to them. But it turns into a matter of who wants to make that jump and really call out the responsibility. Because yes, the standards already say it, but who's gonna be the first one to step forward? So that's really what it turns into. So this is in Colorado. You guys think across the North America is higher or lower for initial curing?
Lower.
Lower? Higher? Lower by 10% or by 8% actually. So, and just so you know, this includes California, Southern California, which actually put in quite a lot of observations over the last year, as well as Iowa. Now I'm trying to remember who it is. Kansas City, Iowa, Missouri, Colorado, Canada. Texas has some in there as well, but it's just Dallas-Fort Worth. But yeah, it's all across the country. Georgia just started, so Alabama is one of the ones that we're going to be onboarding in the next couple months. So, but that's across the country. And it's like, so it's not just a Colorado problem. That's from what we're seeing, just in these observations. You know, it's like, now, are they representative of all of the concrete testing that's happening out on projects across the country? It might not, but it's like the more observations we get, the more information we're gonna see that really truly is represented.
So as producers, all the cost savings and CO2 that you're saving on 1L, we're having to over-design mixes to compensate for 85% of wrong initial curing.
Karthik Gobla from NRMCA, he has quoted 11% of the over design in concrete mixes is due to poor testing or the expectant of poor testing. So if we're able to improve testing and create a more consistent testing result, and it's like that 10% of our carbon creation is going to be reduced as well. Yes.
How long have they been doing cylinders like that, like this? Curing and,
Curing incorrectly, you mean?
no, just in general. I mean, because with that low of a number, to me, it almost makes me think that the way we're testing it needs to be reevaluated. Is there a better way that we should be curing and testing cylinders? I mean, that's a pretty low, even on a nationwide.
Mhm.
We start
It's,
thinking about maybe,
it comes down to enforcement is what it comes down to.
which is really hard to do in the
Is,
field, right?
yeah, it's just, it's not, you're not able to do it unless everybody on that project has that same consensus.
Right.
And it's like, that's the only way it changes is project from project to project to project.
Well, like what he was saying, it really comes down to, are we meeting strength? That's what the
Mhm.
acceptance criteria for the project is. You have to meet strength.
Well, yes,
So in order to
so,
get that.
so we're meeting strength
over-design-
by over designing.
Yeah, yeah.
Yes.
So we're, so unless we're having problems with strength,
Mhm.
we're not really gonna worry about the
Yeah, and
initial current state because the producers are just
Yeah,
having. to
and
put more cement.
ultimately, I'm not going to pick on GCC here, but it's like, it's not like we're trying to reduce their sales. And it's like in cement, and it's like, but globally, we have to reduce carbon. We have to reduce it, and it's like, there's no way around it. We're stuck in it. It's going forward. We can't change that course. So if we're not able to fix this problem, and it's like, what other problems are we not gonna be able to fix?
What is the biggest factor in getting people to change? Money. So if we can't charge these, as a producer, we charge our contractor and tell them to back charge the testing agency for bad testing if we go out there and core. It's been pretty darn successful. When you tell, hey, take this, send it to the GC, bad testing. Back charging, put your 10% on top of it. Money's a factor for everything, right?
Yeah, yes, and without getting into the details there, yes, money is a factor, but the moral issues there is that there's always somebody that's gonna charge less.
No.
So in order to curb that problem, we have to figure out how to increase everybody's responsibility
So
at the same time.
you've been in this for 25 years, I've been in this 12 years. Started in testing as well. 2011, I didn't store cylinders correctly. 25 years ago, did you store them correctly?
Oh, no, I didn't.
And I mean, at the end of my career,
I didn't know better 25 years ago. I didn't know better 20 years ago.
even now as ownership of third-party testing, you see some of them that care a lot, some of them still sending out same roll insulation that they bought last year in a cooler in the evening.
Yeah, personally, I did not know I was doing it wrong until I got my professional engineer's license. Then when I started stamping reports as a supervisor, I started paying attention. And it's like, so that was me taking that responsibility. But I know that it's not consistent across the board yet.
And I mean, devil's advocate, have you seen any change because of CTEC?
I don't have the information here, but we did see change up through, up
The COVID.
until COVID.
And we got.
Let's put it that
We
way.
all know COVID.
Because if for specifically, let's look at the Colorado numbers again, and it's like, we're down to 24%. If I look year to year, 2015, 16, 17, 18, and 19. If I look at every one of those years, we were anywhere between 40 and 60% meeting requirements for initial curing. That 60% was in 2018 and 19. We were seeing that increase. And I know some of that was due to conversations that people would have about about what they were seeing based on that. But that was also me, as the administrator of the program, looking at it and saying, okay, what can I do as a representative for the industry to improve improve initial curing? So in 2017, I was seeing the numbers from the first couple of years of this program, and I changed the way that we did our Field 1 certification training to emphasize initial curing more.
Nice.
And so that's when we started seeing it a little bit more. And that was when Martin Marietta was submitting 75% of our observations as well.
My name on there. I guarantee you, none of mine. That initial cure.
Yeah.
Go back and
So-
look at 'em.
So we spent quite a bit seeing some changes, but we're starting to see some lower information. Some of this, it's like we can see what the different initial curing environments are just from the last 2 years, as well as the red line, which is overall all time. But this one's more telling here. If you can see, it's like min-max for monitoring control. That's upwards 50%. So these are the observations of when they did what they saw out on job sites. So 30% of the time they have not seen anything, or actually 33% of the time overall. People have not seen any temperature monitor or control. And no, these numbers will not add up to 100, just so you know. Because sometimes you will have thermostatic control, cool and heat, or one or the other, not always both. And it's like, but 50% of the time, or even 30% of the time, we're doing having min-max. 33% of the time, we have nothing. The other 33%, we have something else being utilized. But that right there is telling us that we really need to pay attention to what we're using, or making sure that these technicians have the equipment, have the power to set up the initial curing properly.
Is there data showing differences from, say, one set of cylinders cured properly and not cured properly?
I will hand it over to Mike for
That's
that
exactly what we're
discussion.
gonna
I've
talk
been
about.
thinking the whole time, like, when are we?
JT,
Yes.
it sounds like there's some questions in the chat.
Oh, okay, let's see.
So literally what we go through right now is large studies that have been done to analyze what happens if you do improperly cure cylinders. So in general, if you look at high heat early, you're gonna have a hard kick into hydration. This is like this 100%, 140 degrees down to a very slow initial curing at a cool temperature, just barely warm enough to keep the concrete hydrating. And in general, the 73 would be the perfect curing conditions for the ASTM standards. If you give it that higher than specified temperature, you'll get early age strength, but your ultimate strength will never reach what it should have if it's been properly cured. And you actually get a benefit on 28-day strength if the cylinders are cured in an environment that's cooler than the specification. And that trend plays itself out when you look at the data. So this was from Dr. Anton Schindler, his project for 1 day of non-standard curing. By taking them as high as 140 degrees, they were losing up to 17%, or overall average 17% strength loss compared to the ones maintained in a proper curing environment. That's just for 1 day. And if you go to 2 days, this is another project for 2 days, but looking at different SCM combinations. So they looked at if it's just a type 1 cement on the top column, or a type F fly ash, it's actually pretty resilient, but doesn't gain as much heat by itself, versus the class C fly ash is a little more sensitive to higher curing temperature. Silica fume extremely sensitive to a higher curing temperature. And the worst was a F fly ash, 10% silica fume combination. So, in general, high heat is gonna give you skewed results. So when that example that you saw with the black cylinders out in the sun, that's probably gonna get too hot. It's probably gonna get you some bad low break results. So what do you do with this information? And reinforcing that, there was another team that did a couple hundred cylinders. So the green represents the standard curing conditions. They go about 6,000 PSI. They gained about 10% by putting them in a cooled environment. They lost 45% by putting them in an oven around 140 degrees. Lost 12% in a hot cure tank, no temperature cooling on it. Kind of reinforcing that. You'll actually get a benefit from initial cold curing, not representing what it really was. So this was Test Fest in Grand Junction, Colorado in February. We hid the names, although we will say that this was the reference standard of the CDOT. They basically took the sample to the lab and then molded the cylinders there. So to me, the most interesting column is versus perfect curing environment. Pretty much all of these were having a low initial curing temperature. Only the one in the oven was exposed to a extremely high outside of the standard curing condition. It lost 30% versus what the same concrete in better conditions was represented by. The rest of them, in general, this was in a cooler than 60-degree environment for a lot of the time. So they were actually doing pretty good for not having temperature controls. And they were basically in the 90 percentile for most of the samples. Only the one that went straight to the oven that lost 30%. So going back to address the high-low thermometer, I just got these little switch spot sensors and sent out like 30 of them around to different contractors and said, put these in your initial cure box to see what we get. It'll literally take a reading every minute. There's other devices in the market. I'm not endorsing anything. I'm just telling you what's out there and what's being done. Basically, these I think monitor 15 minutes. Some of these other ones will monitor every 15 to 20 minutes. This is not waterproof, the switch spot, which I didn't realize until it spent a month in a ready mix producer's cure tank and didn't survive a day, literally. So it's they're inexpensive. If you're in a dry condition, it's just fine. They should last a long time. But if you really want accurate data, these other products are focused on the specific concrete curing environment as opposed to something that was literally for agricultural or just have around your house type of environment. But they're pretty darn cheap. And I would say if you can, this is probably better than nothing. And these would be an upgrade from that. Also, I don't want to talk about money, but they are more expensive. You're getting the trade-off in quality for cost. So we go question.
I know we're
You want
not
me to take
talking
this?
cost, but ballpark, what are those?
These things,
The
they're
geotechs
less-
are expensive.
these less than $20.
I was gonna say anywhere from 20 to 150 bucks.
Geotechs are like 60, and they'll get cheaper. They get a whole bunch of them.
Yeah.
And the other ones will be like one over 100 or some of those.
I've used the hobos and you can get them for 50 or 60.
Yeah.
They're the pendant data loggers. And they
Yeah, when
last
I used them, we had to plug them in. So before we get into some general questions, we did have during registration, several questions that came through. I just wanted to point out just a handful of them real quick. So how far is too far to move freshly cast cylinders? That is part of the initial curing requirements. And honestly, there isn't a specific answer. Some people say 15 feet, some people say 100 feet. I was answering this question while I was in my house, and I've got a open area house that has about 50 feet between my bedroom and the laundry. And I thought that was too far. So my realistic idea, it has always been right around that 30 to 40 feet is your ideal distance at most. Ideally, theoretically, you should be sitting right next to your initial carrying environment. So the coolers are sitting right here in that secure location, be it in a storage area or a cooler next to a shed, whatever it may be. Your truck's right here, you're testing right here. You're creating those cylinders right there next to that location. That is the ideal location. But if you have to carry them, that's probably as far as you want to go. What happens to concrete when it freezes? That question came up, I think on three different registrations, which I thought was kind of interesting. We're not going to get into that completely, but understand just based on some of the information that Mike shared. It's like hot temperatures reduce the concrete strength. Cold temperatures don't necessarily reduce the strength all the time. But when it freezes, it creates a slowing process of that hydration that's required in that concrete for it to meet strength. So it may bounce back a little bit, but if you freeze it, technically it is not going to get back to full strength. And it's like those cooler temperatures that it started off with, and it's like, yeah, you might still get strength, but you're losing a lot by putting them in freezing conditions. And when I say freezing conditions, that's below 32 degrees. There's a reason we have 60 to 80 degrees as that range that those cylinders need to be sitting in, because they're going to hydrate. Did somebody have a comment? I saw a couple heads nod. I don't know if you guys wanted to speak on that a little bit. No? Okay.
Well, when it freezes, you're growing crystalline.
Yeah.
Your ice freeze if you're blowing the cylinder out before it even has a chance to.
Yeah. I wasn't gonna get into the details.
No.
That's no good. Yeah. So what are the initial needs in cold weather? We've already talked about some of these issues, but since it was asked, we do have a cold weather concrete seminar for Tech Tuesday that's gonna happen in September. Put it on your calendar. So we will talk about that. Is testing valid if standards are not followed? Basically, no, because standards are standards are standards. And it's like, I don't care who you talk to. Standards are black and white. Either you follow them or you don't. If you don't follow them, you're not meeting the standard. Therefore, those tests are technically not going to be valid. That's really how you have to look at it. But and it's like you have to really just have that conversation with your project team to really determine, okay, what is acceptable, what is not. Because if you're not following ASTM C31 and the project team is okay with that, you need to make sure that is correct, that is there before the project starts. Because now what you're trying to follow in the specifications that say you must follow ASTM C31, that's not true anymore. So now you have to make those changes. You have to have those conversations beforehand. Would you want bad test results from initial curing to represent good concrete? I didn't want to say it again, but the simple answer is no. And it's like, if you have good concrete, if Josh is bringing concrete out on job site, and it's like it meets the mix that he is required to provide. And it's like, if the testing doesn't reflect that, is he gonna accept that? No. Is the contractor gonna accept it because he's paying for it? He shouldn't be. Testing agency should be making sure that they're doing it correctly. Yes. And it's like, and that's really what it boils down to. One of the comments in the chat earlier, and I responded to was that, and it's like, there are testing agencies that know what their requirements are and they just don't care. They just don't do it. And that's true, very true, that there are some testing agencies out there that do that. And that's what I was kind of alluding to the morals of the industry, right? And it's like, you're going to run into those, so you have to have those conversations beforehand, and that's really what it comes back down to is that communication. And it's like, utilize the tools that are available. It might be CTAC, it might be something else, it might be a different program, it might be the initial carrying bots or pods to put into those initial carrying tanks, whatever it may be. Use the tools that are available and have that communication. So with that, what do we got on online?
Comment, be careful about taking the position that the test is not valid. If invalidated, it leaves a gap for you to prove performance another way. I guess if you're not performing the initial curing properly, that's the thing to fix. I mean, granted, it's cow's already out of the barn if you're having, if you know that it's being done poorly, but.
Yeah, if
That's
you
why
know
you-
something is being done incorrectly, you know what you can fix. Absolutely. So it's, but with other performance aspects to the concrete, and it's like, well, if you already know there's one performance aspect not being met, you can fix that. And it's like, you can go into other performance aspects. You can go to coring, you can go to testing the air content on hardened concrete, whatever it may be, to validate that concrete meets the requirements. But why go to that further step? Delay the project, increase costs on the project, cause butting heads on the project. Now all of a sudden you're not working as a team anymore. So have that conversation.
Instantly it comes back to pointing the finger at producer. What's wrong with your concrete mix? Everything was done correctly. Okay, I got all the documentation saying it wasn't. Well, how can we prove it's right? We can Windsor hammer. Nope, we all know that's crap. Our Swiss hammer. Windsor probe. What's a Windsor probe? Rolling average 3. No, we need actual cylinder breaks on the material in place. All right, coring it is. Let's break it up. So you go through the whole list of non-destructive to end up at destructive.
Yeah.
And then hopefully you're missing major reinforcing or
Well, that's-
cables and all the other stuff, and if
Then
it's,
you call a specialty guy out there and
Yeah.
get your GPR going.
And that's one of the key things behind CTAC, and not to sell on CTAC again. But it's like, when you were with Martin Marietta years ago, and it's like, we had observations, and it's like, I've had conversations and meetings with producer and testing agency at the same table and say, hey, look, we got observations right here. Concrete was done, it was tested correctly for these 3 pours, but not this pour. You've got low breaks on all 4 pours. Now let's figure out what the problem is on these 3, because we already know the problem here. And it's like, you can start dialing down what those issues are before you even get to that conversation of, okay, well, what other tests do we have to spend money on?
And then you're, like you said, then you're holding up the project, you're slowing down the timeline and trying to get the answer and make everybody happy.
Any other hateful responses there to what I just said?
not specifically, but when I was a concrete contractor, this dealing with low breaks takes a lot of energy and effort and a lot of distraction. And I can't think of one time that after taking cores, that the cores were adequate. Because basically it was representative of what was, ready-mix producers are inherently conservative enough to give you enough powder to get to the strength. And then it becomes, how was that sample handled, whether it was dropped or improperly cured or whatever, before it actually made it to the testing apparatus. So it was extraordinarily rare to take cylinders and have those not meet 85%. But I mean, it happens. I mean,
Of course.
but.
Yeah.
So with that, it's like, I think you had a question, but just for you guys that are online, I did allow access for you guys to unmute yourself if you'd like to join in the conversation right now. We'll spend another, I don't know, we'll see 5-10 minutes depending on how long this conversation happens, but you guys are welcome to join in. Stan, what was your comment?
I had a client that I thought it was rather clever. They put in their bid documents to contractor customer that they will not be responsible for any low breaks if there's not a digital recording of the temperature that proves proper initial curing.
Mhm.
They don't allow high-low, which I've seen it, gets pencil whipped. So I actually contacted a staffer at ASTM, and he kind of showed me the process. I still need to go through. But what I want to do is put in a request to C31 committee to put in, not just temperature will be measured and reported. It's not happening.
Continuous.
It needs to be a continuous digital log that is part of the test results that have to be, basically saying, we're tired of this. You have to actually have a log that shows you actually achieved 60 to 80. And if you don't provide that as part of your test result, the test result is invalid. End of story. And force it to be a requirement.
And yeah, and there's that two-step process, and I have to say, CDOT has done good about putting that requirement in their standards, saying continuous, because for at least those long-term projects, the paving projects, they require at least the wheel
Right.
to be continuously monitoring those curing facilities.
I think we're
But
seeing,
it's that enforcement that we have to get that hurdle over.
what I'm seeing and hearing is there's a lot of CDOT specs that are being used on municipal projects that have some CDOT funding, so then the CDOT, these municipal local project entities, I term, they aren't putting out the proper CDOT trailer, they're hiring consultants and they're just winging it.
Mhm.
So, I don't know.
It goes back to communication, having that pre-con, talking at the beginning. I know this is a broken record, right? But it's like at some point we have to get to the point where it's like, for lack of a better pun, it's like we got to break that brick.
How do you get people to care as much as you do?
What's that?
How do you get people to care as much as you do? That is the question.
You have to put the responsibility on them. You have to create
I mean, as a technician 25 years ago, did you get sent out with all the proper gear? And
well,
I can tell you
that's
my whole-
unfair. 25 years ago, I started my career.
Well, okay. My whole 5 years as a field technician, I never got sent out with the right equipment to initial cure properly.
That comes back to what Mike said earlier
To the
about having the
ownership.
support.
Having that
Have
support,
working
yeah.
for somebody that's willing to spend the money.
and that's-
give you the
that-
equipment and-
Yeah, that's one of the comments that I have with testing agencies for CTAC is, and it's like, yeah, you wanna look at it as a finger pointing device and it's like, oh, these guys are out there telling me that and my guys are doing it wrong. Well, have you had the conversation as their manager about what they have, what they need? Do they understand the procedures? And it's like, and that's the conversations that you have to start having. And it's like, because if the managers care, it's like you have to share that with your technicians, no matter what side of the concrete testing you're on.
Absolutely.
So JT, can I make a comment?
Absolutely.
Okay, so I'm a concrete contractor. The most effective thing that we've found that has turned things somewhat around, probably since COVID, is my team and I travel. We work all over the country. When we go to a place, we previously just visited the supplier, set expectations, and actually held a pre-con with the supplier, and then had follow-ups. We've added the labs to that. And I've had actually more positive response than I thought I would have to walk in the door of a lab. But as a contractor, the way I found to solve it is to walk into the lab, set the expectations, and let them know that we're there to work with them
Mm-hmm.
and to facilitate with them what they need. They need to let us know, but I'm going to let them know right up front what I need. And we try and work that out in the background so the owner doesn't have to worry about that. On the projects that I can. There are other projects where the client owns the lab and I just have no choice. But opening the communication with the lab and not making them the villain has
Yes.
Who knew, right?
Yeah. Well, it's either the producer or the testing lab that are the villain. It's just a matter of which side you stand on. So. But yes, no, I completely agree. And you're down in Texas, right?
I am, but like I said, we work across the country. 50% of 60% of our work is in Texas, but the rest of it is all over. So.
Yeah. Yeah, no, that's a great idea. And it's like as the producer, and it's like have that conversation. No matter if you're involved in that pre-con or not, reach out to testing agencies and sit down with them. And so that's a great way of doing it. Any other comments or questions?
This is NRMCA's got a whole committee of people who are trying to address this. Some of them through the code, some of them through state DOTs, some of them through state legislatures trying to get. But really the most effective and quickest way is to be on a specific project to say, why don't we just do this project right? Why don't we just really follow the standards and just have cylinders represent the material we're getting? You can do that tomorrow. I mean, you can fix a job that's going improper curing today, literally.
Yeah,
You don't need a legislator to tell you it's a law and it's someone else.
Yeah.
Yeah, we start taking advantage of some of the technology that's coming forward, like maturity meters.
Or that has been here
It's been
for
here
years.
Yes.
That's the elephant in the room that no one's talking about. Like, if we started using maturity meters or like some of the resistivity training or permeability, durability type testing instead of strength, like, what do we even need cylinders for?
Well, in regards to maturity, I will say it's a great conversation to have, and it's a great tool to use to subsidize this.
Yeah.
But remember, maturity is meant for emplacement, not the standard comparison of meeting the requirements of, hey, is the producer providing that and providing the right material. But I'll point out, sorry, give me one second. I'll point out that maturity, I think there's still a disconnect in the knowledge of it and the usage of it. And I'm going to point out to Bo Radovich over here. It's like I worked with him at Caesar a few years ago, and he was tasked to take on MIT testing and through that company. He dove into it, learned everything for it. He turned into an expert through MIT. We need those individuals that are doing that are trying to sell maturity meters or trying to put it into their mix designs to say, hey, let's use it on these projects, to understand it to that level as well. And because there's that many little things in maturity that have to happen consistently to make it work.
But even if you just use it as a temperature monitor,
it's definitely even more,
60 to 80 degrees, you can prove like the data's there.
If you're in that range, your odds of it failing.
If you're down here and you're occasionally getting in there for like 1 hour, but you're not.
I mean, this is like future case, like there's been talks, I've been in conferences where they say strength is like on the way out, like to a degree. It's not, it's a new way of thinking. It's,
I hope
this new low carbon stuff has a lot to do with it, because we want to cut cement.
Sure.
We're not gonna maybe see the strength that we're putting in now, which is probably over designed by 25%.
Problem.
Because of these variables that we're having to deal with on testing.
Yeah.
Go ahead.
So
I think I'm right when I'm saying this. I bet everybody's gonna agree. This has all been exacerbated worse by type 1L. I think. Certainly on the cold side, I don't go on the hot side, and I'd like to hear on the hot side, like over, sunny, hot, wrong conditions that way.
I would say that for 1L, we jumped in thinking that it would do one thing and it's doing a different thing. Everybody said that it was a 1-to-1 when it first came widely here in Colorado, where it's and even I tried to say it back then, is that it's not technically, it's close, but it's not. And everybody is starting to see that it's not a one-to-one, and that's what the expectation was at the beginning, and that's where we're faltering right now, is we're trying to catch back up.
Is it effective? I've seen it myself, cylinders I've been on the cold side, but is it as effective when we're over 80 degrees? It's worse. Anybody know yet? Just curious.
I think it is,
Yeah.
but hard to prove it, but yeah.
How many
Go
hours
ahead.
do you have? How many hours do you have to talk? Because
Well, this is Joe Greg. This is Joe Grego.
We have our tech committee at 1:30, but this is our tech committee at this point, so that's fine with me. I am not going to push anybody away from this conversation. Absolutely not.
Hello.
So, any other conversation?
Yeah, JT, can you hear me?
Yes.
Okay, CRMCA 33 specifications have always limited the tolerances on -200 materials to, 1.5%, 3%, depending on which aggregate you're looking at. Now, all of a sudden, all we're doing is putting materials that are -200 materials into our cement now. And for years, we've been told, excess -200 is going to reduce durability, increase permeability, any number of things, increase creep, things like that. And now all of a sudden, because people are worried about carbon taxes, now they're going to, let's throw in roughly another 1.5% to 3% or more now that we're increasing the limestone content into the cement. So we're doing everything that for years engineering community had said you shouldn't be doing that. Amen. So yeah, there is a problem with 1L cement. And not only that, the water reducers that we are using, the polycarboxylates, those react with cement. They don't react with the 1L limestone in it. So what's happening is you get that 1L limestone in there, and what it is doing, it is starving for water. And so it is fighting the cement for the water. And that is why we are seeing lower strength.
Yeah,
Plain and simple.
You have to agree to an extent, but I think that last comment, that's why we're seeing lower strengths. I think that is a falsification of the transition.
No, not at all.
Because yes, we have different materials. Yes, now we have to determine how we're doing and making our mixes and adjust those mixes accordingly. But if we're at least in specific to like initial curing and standard cured specimens, and it's like for any project in the lab or not, if you're making those specimens in the lab for the mix design and they're breaking at a specific strength, they should be when they're being cast out on site as well. Those should be correlating. That's the whole purpose of C31 and C30. Oh shoot, now I can't remember the other one. 94, yeah. And it's like to actually correlate those samples that are cast out there on projects and cast in the lab. They're supposed to be matching up.
Yeah, but you're never going to have that because you're going to have hydration that takes place from the ready mix plant to the job site, whereas laboratory cement or laboratory cylinders are not going to have that same process.
You can still get the correlation though. If
with 1L cement, that correlation is completely different, JT.
So are you saying that if you made a mix design, it doesn't matter if it's an optimized mix design, a standard mix design, whatever, a mix design at a lab at the side of the plant, you get specific strengths, and it's like, let's say it's 5,200 on the plant. You have one specific project that you're sending that mix to that's 20 miles away, and you're getting consistent strengths at 4,800. You can't say that those are not correlating. They are correlating. You're getting lower strengths at the project, that singular project. They might not be the same strength that you get at a different project for that same mix.
Well, in a
because of,
perfect
because of
world,
that hydration process that's happening, but you're still seeing the correlation. That's my point there.
well, in a perfect world, you're gonna have the test labs take care of the cylinders as well, especially since C31, C33, C94 all outline what they're supposed to be doing. And yet they still ignore that, especially if you look at the CTAC statistics on that. So that is your example is a utopian view of that. And not only that, one last thing I'm going to mention.
Theoretically, yes, that's all I was saying is theoretically, but
Yeah, theoretically, yeah, I can talk about this all day long, and it's not going to make it any better.
yeah, for every project is different, and just like what Mike had said earlier is that it's like NRMCA has a whole task force that is trying to combat initial curing and the issues with it, and it's like. He said it there, is that it has to be on a project by project basis. So the same thing here is that if you're having issues, if you know that there's issues in regards to initial curing, you can fix those.
And but see,
Very
that
easily. And you can at least get one step closer.
Yeah, but what you're saying is a project by project basis. That's what ASTM standards are for, is to cover all projects. So if you start saying it's a project by project basis, then what good is ASTM? So
No,
ASTM
what
has
I'm
to have
saying is,
don't talk. Let me finish my statement, please. ASTM those standards are there for a reason. So NRMCA has to also make it clear, and that has to be part of it. It can't just be on a project by project basis.
well, no, I'm saying, and standards are the standards are the standards, no matter where you are, what project you're on. What I'm saying is that if you're having issues on one project, you should be paying attention to that one project and making sure that that project is, the issues that are on that project are solved. And it's like the standards that you're following are the same for every project. I'm not saying that, oh, the standards should be different for every project, but you can solve some of these issues on every individual project at a time. And if you just look at it as, oh, well, I'm just gonna fix it for everything, you're not gonna fix it for everything. You just said it yourself, is that, and it's like it changes depending on where that concrete's being delivered.
JT, you got somebody with a hand up. Biddle?
Oh, go ahead.
Thank you so much. Christine Biddle with the city of Arvada. I was hoping that you could speak to the importance of topical curing after the placement of concrete, as well as the timing of curing the concrete.
That's one thing that we haven't been talking about today in regards to topical curing of the placement itself. But I can definitely share with you separately. We've got some documents called Concrete in Colorado, that talk about the timing and the requirements of that curing.
That would be great.
And as part of flat work finishing as well, yes.
Which is coming up.
Yes.
Yep.
Thank you so much.
Of course. So I will go ahead and just cut us off there, actually, so. What's that?
One more thing, whoever mentioned C31, I've got a note of that, and if nobody else will raise it, I will raise that, about continuous monitoring. I know that's a discussion we have frequently, but it's always good to have more backup from the industry writ large that needs to happen. So I'll carry that forward.
Thank you.
Well,
I'm sure Stan Peters will reach out.
Yeah. One last thing.
I think we all agree with that one.
Well, one last thing. We were all talking about technology. We were one of the early adopters in the state of Colorado to use Smart Hatch. And we found that is the testing and the data that we're getting from that is very accurate. And we have now adopted it and have used it in most of our trucks in South Dakota as well. We're starting to get specifiers to recognize that this is valid. And I just would encourage others to start doing the same thing because it tells you real-time data as far as slump, air, and temperature content, or temperature of the concrete inside the mixer drum. And, we're talking about maturity meters being used to possibly help with strength, even though they really don't correlate, as JT has pointed out. But real-time test data that the Smart Hatch provides, which CRMCA definitely helped us with, that is, I think, the way of the future instead of this 100-year-old air meter that everybody relies on now that can be manipulated or not calibrated properly.
Definitely, I agree. You still need to reach out to me to get involved in that too, by the way. Take a look at that stuff, but I digress. So I will say thank you guys for being here, having this conversation, listening to us rant and rave about initial curing and other little things. But just for you guys' reference, I am JT Mesite, Michael Hernandez. Mike Eads was not able to be here to help us present. Up in the corner is a QR code to our upcoming for updates and events. So any future Tech Tuesdays will be posted through that blog page. So keep an eye out for that. Otherwise, we will be promoting that stuff as well. And then next month in May, we'll have ERS presenting the hot weather concrete in May, and what we're going to be doing for that Tech Tuesday is we will actually have ERS will be presenting down at the Burnco offices in Colorado Springs, and we're going to have watch parties both here, up here, and so we'll have the Zoom live up on the screen here, so we can actually be here in the room all together, and then we'll actually have another watch party out in Grand Junction as well, where we'll have a group of people out there, and then also obviously the Zoom option for any individuals. That registration is going to be coming up soon, and keep an eye out for that. So,
JT, will these slides be accessible?
yes, I will be for anybody that was able to register. I will be sending out a follow-up with a link to the recording for this entire presentation, as well as PDF of the PowerPoint as well as a couple other documents just for reference. So, all right, thank you very much. Thank you guys online. I appreciate you being here.
Thank you.
Thank you.
Nice meeting you too.
I get the best one out of the business. Oh, except for also have
Yeah. Yeah.